with grade 11 geometry. And my experience was that it is because of the theorems. They don't know the theorems, they don't know how to use it, and therefore they fail geometry. So from a number of years ago, when I say number of years, I'm referring maybe to 25 years ago, I started to present geometry slightly different. And that is what I would like to share with you. This sort of approach is what we've put in the Neo Grade 11 book as well. You will see on this first page, it's written there, Group 1 theorems. So you have the notes. If you page through them, we will go through them. Then you will notice there are 3 groups. Now, to quickly tell you, the thinking behind it is that if you look at the first 3 theorems, those theorems are about the center of a circle. And the second group is about cyclic quads. And the third group is about tangents. So what I like to do is when you start your geometry, grade 11, you start with the theorems, but you don't do the proofs. Because our average learners, weaker learners, struggle with the proofs. And then they get lost and they can't do problems. So I like to discuss just the theorems. As you can see on the screen, I've got the drawing there. And I discuss so that they understand what the theorems say. And I do in one session the first 3. So group 1, I do in one session, one day. They don't get any homework. You don't do any proofs. You expect them the next day to know these 3 theorems. And when I say know them, I refer to the wording and the drawing. The wording don't need to be perfect, just more or less. And then you continue with group 2, same procedure, and then with group 3. So you can cover the 9 theorems in 3 days without any big problem, because you're only going to discuss 3 theorems per day. But you must make sure every day they know those 3. And then we start with some problems. Now, I did it a little bit different today. I've got the first 3 theorems, and then I've put in 1 or 2 examples, but these examples are only on these 3 theorems. And then I do it for the group 2, and I also do it for group 3. So I'm quickly going to go over these theorems with you. So just sort of to give you an idea, maybe on how to discuss it, but you can also use your own approach on how you would like to discuss it. Now, I didn't put the wording in, I only put the drawing, but you will most probably remember it. If you look at the sketches, you will see the line drawn from the center of a circle to a chord, and then you will notice it bisect the chord. So the bisect was given to us, so therefore it will be perpendicular. Now, I like to discuss both of them. If it bisect, it's perpendicular. If it's perpendicular, it bisect. So depends which one is given. I found that kids get confused. They think if they just see the drawing like this, they can say it bisect and is perpendicular. So perpendicular will bisect. If it bisect, it will be perpendicular. So that is basically, so I just like to, this was the wrong choice. Let me just get my pen. I just like to make a drawing. I asked the kids to draw this as well. And so that they have their own, it doesn't matter where the chord is. And then we say it is perpendicular. Perpendicular means it will bisect. Bisect means it will be perpendicular. So now we always do a construction. For all the theorems, I do the same construction, and that is draw radii. So I've got the radii in, and all we do is we now prove the 2 triangles congruent. And this is the time where you quickly can revise congruency, the 4 cases. And as you can see, this is a right angle, a hypotenuse, and a side. So this is RHS. So they are congruent. So therefore, it will be bisected. And we use the same approach if we go backwards. So if we know the bisect, we also draw radii, but then you will agree we have side, 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 and they are congruent. And my experience is the kids find this easy. So you explain and you explain the drawing, explain the wording, and you move on to the next theorem. So that is the second theorem. And this one says the anglet center twice anglet circumference. I added a few drawings, but to start with, let's look at the acute angle. And yeah, this doesn't look good. Sorry for that. I will try again. Yeah, but in any case, gives you the idea. So we also draw a radius here, right through the origin. Let's call it O12. Let's say this is A12, and let's say this is B and C. I just apologize that my drawing is not neat. But in any case, if you look at this drawing, we want to prove that this angle at O, O1 plus O2, will be twice angle A. And we want to know why. So if you take them back and remind them of one of the definitions from grade 8, where we have exterior angle of a triangle, but I in particular want this obtuse angle one. So we know that this angle is equal to that one plus that one. Now, if you look at this drawing, you will notice that that is what we have. If you look at O1, you notice that ABO is an obtuse angle triangle. So O1, we can now say, because of that, will be equal to A1 plus B. And the reason is the exterior angle of the triangle. O1 equal to A1 plus B. But we know that A1 is equal to B because those two angles are opposite equal radii. So those are angles opposite equal sides or radii. So that means that O1 is equal to twice angle A1. Now, we just proved O1 twice A1, then it's quite logical that we can do the same with O2. That O2 is equal to A2 plus C, but A2 is equal to C, so therefore O2 is twice A2. And that means the angle O1 plus O2 is twice angle A. So it's not very difficult to understand this. You have these three theorems in a session to discuss, and you will see it is not difficult to do it. The third one is quite an easy theorem, and this one say, if AB is a diameter, then the angle in a semicircle, that angle in the semicircle will be 90 degrees. So given to us, we will notice it goes right to the origin, so it's a diameter. So that's the condition. Then the angle will be 90 degrees, angle in the semicircle. All right, let's just quickly talk about this one. My circle, my diameter, and then I draw an angle in the semicircle. Now, the theorem now claim that this angle, well, this is a straight angle, sorry. This angle will be 90 if this is a straight line. Now, it is really easy Because if you look at this angle, if I just name it, that you just understand what I'm talking about. If you look at BC, it's a diameter. So you agree that this gives us an angle at the center. But it's a straight line. It's not like in our previous one, the angle at the center was twice angle on circumference. Angle at center, twice angle on circumference. Now, on this one, angle at center is 180. And this angle is twice angle on circumference. So I think you will all agree with me that it will be 90. So it's a very straightforward one. And we use basically the previous theorem to look at this one. So this is group one. It's on center. So all three of these theorems, the condition is there must be a center. If there's no center, these three theorems are not applicable. So I put in a few questions. They're not really difficult, but I would like us to discuss them just for the reason, not about the solution. I think all of you can do it. I always like to start with numerical problems, that we don't make the problems too difficult for a start. So if you look at this one, and now I would like to sort of explain to you how I like with grade 11s and 12s, how I want them to approach it. So in your class, I can't do it now because this is now on the screen. I will cover this part where the questions are. I will cover it so that the kids can't see it. Because what they do is they read the question and then they look at the drawing and they hope they can see it. But they didn't look what was given to them. And it's very important that they first read what is given. And that is why I always ask, don't start with the question, but start with the drawing and the given stuff. First of all, O is the center. Now, this is a key word. So that means one or two or three of the theorems of center will be in this drawing. I'm not saying all of them will be there, but we can expect it. There will be. And you will notice there's no cyclic quad. We still need to do that. There's no tangent. So this is only about center. Now, if we look at the center, you all will agree that this is radii because O is the center. This is 90, and this one is bisected. So you notice that that theorem we spoke about, both ways are in here. So perpendicular will bisect will be perpendicular. So I would like the children to start to see that. So I'm just going to mark it so that we don't forget. Those will be equal, and that will be 90. And then they gave us some lengths, AB. AB is 6, so I think because AP is equal to PB already given, it will be 3 and 3. And CD, the whole of CD, that is 8. And the radius is 5. So we've got everything on the drawing. So now they ask us, with reasons, what is the length of OP? Now to go to OP, you notice that is a right angle triangle, but we don't know it. So we first need to say that P2 is 90. So I'm going to say P2 is equal to 90 degrees, that one. And that is a line from center to midpoint. Because that is the theorem I use. It's the line from the center to midpoint will be perpendicular. Now, because that is 90, that is a right angle triangle. So we can now easily say that OP will be 4, and that is where we use Pythagoras. I didn't put more steps in just because of the space, but I think you know what I'm referring to. So that is my OP, and that was the question. Secondly, they asked for PQ, but we have PO already, or OP. So we now need to find OQ. Now, we do know that this is 5. This one is 5. Because this is perpendicular, we must first now write down it will be bisected. So I'm going to start off by saying that CQ is equal to QD. And my reason is line from center perpendicular to chord. So if it's perpendicular, line from center, no, sorry. I made a mistake here. I'm so sorry. In the first one, I said line from center to midpoint. Yes, that was midpoint. Now we on this one, it's 90. No, not a mistake. It's correct. That is a perpendicular sign. That one. All right. So because they're perpendicular, it will now bisect. So now we can say that CQ is equal to 4 because the whole thing was 8. And now we use Pythagoras again, and we can now find OQ with Pythagoras to be 3 because hypotenuse is 5 and that CQ is 4 with Pythagoras. And now finally we can say what PQ is 4 plus 3, which is 7 units or centimeters. I don't think there's a problem so far. These problems are pretty easy. It's more to show you how you must approach it, that we don't look at questions in the beginning. We analyze the drawing and then we start. So this similar question, it's the same one, but only the B part where they ask us now to explain why AB is parallel to CD. Now, it's the same drawing as what we had before. So you'll remember that this was given 90, so that will be equal to that. And this was given bisect, so it will be 90. And we now want to prove those two lines, AB and CD, parallel. Now, I think it's quite obvious. I will start off by saying that Q1 is equal to 90 degrees, and that was given to us. And then I'm going to say P2 is also going to be 90 degrees. We can give the reason again, or we can say we proved it in the previous one, but it is line drawn from center to midpoint. Line from center to midpoint. So that means it's 90. So as you can see now is that Q1 plus P2 is equal to 180, but they are co-interior angles. So therefore, AB is parallel to CD. I think quite a nice little question using only that group 1 theorems. And I'm sure it makes lots of sense for you. Right, I move on. There's a second example, still on group 1, still on center. And this drawing much easier. So if you see, we've got center O, we've got angle A, 48. And the first question is to find O1. Now, O1, once they know these drawings, they can recognize it. So I think you will agree with me that it's quite easy to find O1, that O1 is 2 times 48, which is 96 degrees. And that is angle at center, is twice the angle on the circumference. So that was O1. Second one is B1. Now we have O1. We can start off by saying that B1 is equal to C1, and that is angles opposite equal sides. So I can now say that B1 plus C1 plus O1, which is 96, will be 180, and that is angles of a triangle. And you now will agree with me that I can now find B1 easily, because I take the 96 across, and B1 plus BC, maybe I must just put that down first, and it makes more sense. B1 plus angle C will be equal to, and I must subtract, 180 minus 90 is 90 minus 684. So therefore, B1 is half of that, which is 42 degrees, because I already stated earlier that the two angles are equal. And there we have B1. Okay. There is a third one that I would like us to look at, and it's still on those problems, still the same three theorems. And this one say that O is the center. So here you notice now that O1, if I can just get this, there it is. O1 will be twice C1, because this is angle at center, and that is angle on circumference. So if I can quickly take you back to that theorem, it is this drawing. Angle at center, twice angle on circumference. So the children sometimes don't see it, but it's important that they realize they are subtended by the same arc or chord. Now, if we look at this one, we have two parallel lines. So because of the parallel lines and the 50 that is given to me, I think you will all agree that I can say this angle will also be 50, that O1, because that is alternate angles. Now, if O1, if I know what O1 is, I think you will agree I can find C1. And that will be half of it, because it's angle at center twice angle on circumference. So that means we've got two angles there. We can find P1. I only focus on the ones with numbers. So we can find P1 because that is just with angles of a triangle. Quite straightforward. And that was the question. Find C1 was the first one. We must find C1. And then we must find P1. Now, to get to C1, we need to start with O1. So I'm going to say O1 is equal to 50 degrees, and that is alternate angles, and always, the learners must always also say which lines are parallel. AO parallel to BC. So now we have O1, and O1 will take us to C1. So C1 will be equal to 25, and the reason is angle at center is twice angle on circumference. And there we finish with C1. If we go to P1, we have C1, we have B. So I think it is very easy that we can say it's 180 minus that 25 plus 50. And that is angles of a triangle. And that therefore P1, if I subtract the 75, sounds to me like 105 degrees. So that is another example. These examples, all three of them, are only on group 1. All right. So I hope you are ready for group 2. We're going to do the same thing. We're going to discuss the three theorems. And then we're going to do 2 or 3 problems only on cyclic quads, because that is what this is all about. It's about cyclic quads. And then we will look at group 3, and we will also look at problems there. All right, this one if you look at this drawing again, you can clearly see it's a cyclic quad. Now, just one thing I want to make clear. Many teachers in the past told me that if you have a drawing like this, then you can't assume ABCD is a cyclic quad. I believe you can assume that. The reason is the 4 vertices are on the circumference of the circle. If the examiner don't want you to assume that this is a cyclic quad, then they're not supposed to put the circle. But if it's given like this, it is a cyclic quad. So I'm just going to make the drawing slightly bigger, and that we go over this theorem and what it says. So I'm going to call it A, B, C, and D. What I'm going to do is, like I said before, I am going to draw radii, and I draw the radius to the opposite angles B and D. Now, the moment that I've done this drawing, you will notice that we have angle at center. So O1 will be twice A, and that is quite clear. So angle O1 will be 2A, and that is angle at center. Now the one that children find a little bit difficult, and that is to find the reflex one. And the reflex one is that one. So this angle is twice this one, because that's the reflex angle. You will also remember when we did this one, discussed this angle at center theorem earlier, the one with the reflex angle, I also gave that drawing there so that you can show the kids. So we can now say, without any problem, that O2, I just want to take the red out. O2 is twice angle C, and that is with that same reason, angle at center. Now, if O1 is twice A, O2 is twice C. You will notice I write a few steps, but it's just that they follow. I don't do a formal proof. We will worry about the formal proofs much later. So we can now say, but O1 plus O2 is equal to 360 degrees. It's angles around a point. So what can we say about angle A plus angle C? So A plus C is equal to 180 degrees. I think it makes a lot of sense. I hope so. I believe so as well. So the only thing we do is we draw radii, and we use the theorem angle at center twice angle on circumference. I want you to keep in mind, and just as we discuss, how many times we use this theorem. We used it in the previous one. We use it in this one. And it's a really important theorem, angle at center twice angle on circumference. So this is twice that one. Twice that one, and that one is twice this one, but those two add up to 360, so therefore A plus C will be 180. All right, let's go to the next one, the second theorem on cyclic quad, and this one say the exterior angle is equal to the opposite interior. We want to prove this angle equal to that one. That is what we would like to do. Now, to do that, if I can just make a drawing a little bit bigger. All right, same drawing. We want to prove that D1 is equal to B. Now, it's quite an easy one. Just one thing that you must, ladies and gentlemen, that you really must remember and make sure your kids get that, is that when we are dealing with an exterior angle, it must be one of the sides that's extended. So we can extend that side, we can extend this one, we can extend that one, we can extend that one. So it must be, that is an exterior angle you only get if one of the sides are extended. So with that, now keeping that in mind, a line like this will not give you an exterior angle. Must be one of the sides of the cyclic. So now it's quite easy to sort this out. So I'm going to say that D1 plus D2 is equal to 180. And you all agree that's a line. I'm not going to write down the whole reason, but please, your kids must do it. That's a straight line. And then we can say that D2 plus B is equal to 180. And that is opposite angles of a cyclic. That is the previous theorem we did. So we know now that this angle plus that one is 180. Now, if you look at those two statements, D2 is in both, and they both add up to 180. So that means D1 is equal to B. And there we prove the exterior angle equal to the opposite interior. So ladies and gentlemen, my whole idea with this is that we discuss the theorems thoroughly, the wording, how it works, explain the drawing, that they understand it. And once you've done the group, you can do a few questions. We did it like this in the textbook as well. After the first group, there is an exercise. After group 2, there's an exercise. After group 3, there's an exercise. So that is our second theorem on cyclic quads. The last one on cyclic quads, angles in the same segment. I just want also to draw it a little bit bigger. Something like that. And that is A, D, B, and C. I'm going to do a construction. I'm going to go to the center, and I'm going to draw radii. So let's call this one O1. Now, if you look at O1 and you look at A, angle A, I think it's very clear that we can say that O1 is twice angle A, and that is the angle at the center. Angle O1 is twice A. But O1 is also twice D. That one is D. Same reason. Angle at, it looks like, fine. Angle at center. So I think from those two steps, if this angle is twice that one, and this angle is twice that one, I think you can agree with me that angle A will be equal to angle D. And with that, we proved the angles in the same segment equal. All right. So let's now look at 2 or so questions on cyclic quads only. So ladies and gentlemen, the idea of this is that we don't do a problem only on one theorem. We do a problem on a group of theorems, 3 to be exact. And then we do it for the second group and for the third group, so that they can see how these problems and the theorems relate to one another. It's very important they must be able to recognize that. Now, if you look at this drawing, they say to us in the given part that there are parallel lines. It is indicated on the drawing. And there's an angle of 130, angle A, and that is also given to us. Now, if I look at this, I think you will agree with me when I say that you notice there's a cyclic quad. And there's also a cyclic quad. So we've got two cyclic quads there. So let's see what we can do. In the red one, if that is 130, I think you're all happy that that will be 50, because they must add up to 180. Opposite angles are supplementary. So what else do we have here? What else can we say when we know the 130 and the 50? I would love to hear your answers, but now I unfortunately can't hear you. So let's continue. I think you already see the next step. If that is 130, this one will be 50, opposite angles. This line parallel to that one. Those are alternate angles, so that one will also be 50. And then opposite angles will be 180, so this one will be 130. So there we have a few angles already. So let's now see what they want from us. They want C1. Now C1, we wrote it in there, very straightforward. We say C1 is 50 degrees, opposite angles of a cyclic. And there we've got C1. It was a pretty easy one. The next one is angle F. They want angle F, which is this 130. We can't write it down. We must go first and find D1. So we're going to say that D1 is equal to 50 degrees, and that is alternate angles, and then they must always mention the parallel lines. Now, because D1 is 50, I think you will agree with me. I can say angle F will be 130, and that is opposite angles of a cyclic. So that was not a too difficult question. I think you all know that one. You will notice these questions are not too difficult. So, ladies and gentlemen, I always believe we must not start with difficult questions, because you're going to lose your kids and they're going to get negative and they're going to say, I can't do it, and they don't want to do it anymore. And they don't even want to try. So I want to suggest that you teach them these theorems, not the proofs. They find proofs difficult. We must do it only later. And to understand the theorems and to be able to see them in a drawing. And that is why my problems are not so difficult, so that it's easier for them to see it. And we will build it up as we go along. I apologize for that. The next problem, you will notice there is clearly a cyclic quad. There's clearly an exterior angle. So it doesn't look too bad, this particular question. I don't know if I must write it down for you, because I think it's almost too easy. 40, that one is 35. So you all agree we can find angle A with angles of a triangle. That is really straightforward. So angle A will be 105. Yes, because that is 75. And once we know the 105, C will be 105, because that's the exterior angle of a cyclic quad. If they want C2, of course, is 180 minus that. But they say with reasons C1. So we're going to start by finding A first as 105, and that is angles of a triangle. And then we can say C1 is 105, and that is the exterior angle of a cyclic quad. A very easy one, so let's move on. Now we are at, I think I skip a page. Yes, there it is. Remember, there was still a third one. This one starts to look better. If you start looking at these questions, if I can just take you back, on cyclic quad, this one was mainly opposite angles of a cyclic quad. This one was exterior angle of a cyclic quad. And if you look at this one, you notice that this is angles in the same segment, like angle P is equal to angle S. So we have 50 degrees given to us here. So I think you will be happy if I say S will also be 50, because those two lines are equal. So angles opposite equal sides. So that means we can find this angle. That is 100. So this one, of course, will be 80. So now the question is, they ask us to find P. Now to find P, I basically just need S. I don't need M. But it can't do any harm if they put it on the drawing. So I will start off by saying that angle S is 50 degrees, and that is angles opposite equal sides, because the sides were given equal. And then we can say angle P is 50, and that is angles in same segment. And that's it. Also not too difficult. This, if you do these problems with your learners, you will notice that they will start to build confidence, and they will start to believe that they can do it, and because they get it right. And then you've got a chance when we get to the more difficult ones, they will cope as well. Now for the last three theorems on tangents. Apologize. This theorem says radius perpendicular to tangent. So this theorem says if it is a tangent, so that is the condition, then that angle will be 90. Now, ladies and gentlemen, this theorem, they only need to know the wording and the drawing. We don't discuss the proof with them. This proof is quite a difficult one. This is where you will remember from your tertiary days, we did different kinds of proofs, that we have direct proof. Direct proof is like the previous theorems we did. And then we get a proof which is called proof by contradiction. Now, that is what we need for this one. And that is way outside our syllabus, school syllabus. So we set in the caps, you will read, if you go to the grade 11, the geometry, you will notice we said there explicitly that the proof of this theorem must not be discussed with the kids. It's a very important theorem. We use it in geometry, but we also use it in analytical in grade 12 when we do circles and tangents in analytical geometry. So they must remember the theorem for that as well. So a radius always perpendicular to a tangent. The second one is, excuse me, the second one is two tangents from the same point outside the circle will be equal in length. Now, this theorem, we don't see it a lot, but they can ask this. So I'm just going to do my famous construction of drawing radii. And if I do that, think back of the previous theorem, you all agree they will be 90 because radius perpendicular to a tangent. And that is what the learners are missing very easily. Now, if I join these points, just to divide it into two triangles, then you will agree with me that these two triangles, this one and this one, will be congruent. And the reason is a right angle. This PO is the hypotenuse, and the radii is the side. So it's 90 degrees, hypotenuse and side, they're congruent. So therefore, we can say that that one, this line, equal to that one. That's what the theorem claimed. All right. So that is our second theorem on tangents. And then the one you all know, the very popular one, that they quite like to ask in exams, and that is the tan chord theorem. Now, ladies and gentlemen, I want to discuss this a little bit with you, and I just want to give you an alternative, but I just want to quickly get the center, and I'm going to draw the radii. You're most probably aware that in some of, when we prove this, we sometimes draw a diameter. If you prefer that, absolutely no problem. I quite like to do it with radii because we did it in the other theorems as well. And once I've done that, you will notice that O1 is twice angle C. You can already see that angle at center. But the other thing that is absolutely crucial is that this will be 90. Radius perpendicular to a tangent because it was a construction. So we know this is 90 degrees. I'm just going to call this one A1 and A2 so that we know what we are talking about. I'm going to follow a little bit of a different way, and I'm going to give you sort of the proof how I quite like to do it. And that is to start off by saying, let A2 be equal to X. So A2, I call it X. And that is 100% valid in mathematics that we can do it. So that means that A1 is 90 minus X. And now the reason for that is the radius perpendicular to the tangent. So radius perpendicular to tangent, that is why if this one is X, that will be 90 minus X. So now I want that angle. So this angle is 90 minus X. I want this one, and that is 90 minus X. So I can say, and angle B is 90 minus X. The reason for that, quite clear. Angles opposite equal sides. So now we can say O1 is equal to 180 degrees, subtract the sum of those two because I'm going to work with angles of a triangle, 90 minus X plus 90 minus X. And if you calculate that, you get 2X because the 90 plus 90, you subtract it, and then minus X minus 2X times the negative. So there we have O1. Now, our aim is to get to C because we want to prove A2 equal to C. We can write that down what is required to prove here, that A2 is equal to angle C. And then we did the construction. They must also say that, and then they can continue with that. So now we say C is equal to X, and that is angle angle at center. So just to give you as an alternative proof, my experience when I did this with 11s and 12s over the last number of years, many of them, majority of them told me they find this proof much easier. But it's all up to you. If you're not fond of it, please leave it and use the one where we draw the diameter. So that is our last group. So we have now all 9 theorems. And now we're just going to do 1 or 2 questions, but only now on tangents. So like I said before, they ask us for angle A, but let's not worry too much about it now. Let's first read. You will see we've got a center O. And because there's a center O, and there is a tangent, AB is a tangent, I think you will agree that I can say that will be 90 degrees because radius is perpendicular to a tangent. These lines are parallel, so we have alternate angles. If this is 55, oops, that will be 55. because of the alternate angles. So I like just to sort of analyze and see what we have. And then we can see how we can find the solution. So we've got parallel lines, we've got 55, we've got a radius, and we've got a tangent. Now, I think you will agree we've got enough to answer the question to find A. We first of all, I would like to say that B1 is 90 degrees because we need that. That B1 is 90, and that is a radius perpendicular to a tangent. And then we say O1 is equal to 55 degrees, and that is alternate angles, and that is AO parallel to BC. So we've got O1, 55, B1 is 90. To find A, easy, angles of a triangle. So angle A is just 180 minus 90 plus 55. And that will give us an answer of 145. I think it's 35, if I'm not mistaken here. I think it must be 35 degrees because that is 145. And that is just angles of a triangle. Okay. Not too difficult, but using the theorem, radius perpendicular to a tangent. This one you notice there are two tangents, so it's very obvious it's based on that. So this angle is 36, angle P. Angle P is 36. And they want us to find A2. Now, A2 and A1 are the same. So if we forget A1, we have A2. So let's see how can we do it. If this is 36 and they are both tangents, and that was given to us that they are tangents there, then you will agree that this angle will be equal to that one, because it is an isosceles triangle. Those angles are opposite equal sides because these two sides will be equal. Okay, so I'm going to start off by saying that AP is equal to BP, AP equal to BP, and the reason is those two tangents from outside. Just write short two tangents, then you know. So we know those are equal. So now we can say from this, we can now say that A1 will be equal to angle B. And that is angles opposite equal sides, because we already said the sides are equal. So now we can say that A1 plus B plus 36 is equal to 180, and that is angles of a triangle. And then you can straight go from there to A, because we already said A1 and B are the same. You take the 36 across, you divide it by 2, and you get an answer. This A1 may be what I can do to make it just a little bit more understandable, that A1 plus B, if I take the 36 across, will be 144. And because they are equal, we already said that previously, so we can now say A1 is equal to, that is, I said 44, can be 44, 144, so that will be 72. Sorry for that. So 180 minus 36, 144, divide by 2 to get A1. The question was not A1, so therefore we can say A2 is equal to 72, and that is vertical opposite angles. And then we have A2, and that was the question. All right, let's move to, well, maybe before we move to the next one, I think it's a good time that we quickly take maybe 5-7 minutes break. Maybe some of you also would like. In Joburg, it's quite hot today, so coffee is not going. I would just like some cold water and to stretch the legs. Please, you do the same, and we will start again right from here, where the heading, you will see the heading says mixed numerical problems, but I will explain as we go along. Right, I see you in a few minutes.
Okay, everyone. So while Jurg is taking a quick break, I see there's quite a few people asking for the notes. We will send it through to you, email it to you. And also wanted to mention that they cannot see the notes on the screen. I'm not 100% sure why that is happening. It could be the connection. If I think the majority are able to see the notes, but you can just indicate in the chat if you struggle to see the notes on the screen, and also if you still require us to email you the notes, and then we can send it through. Please also just have a look in your spam folders in your email. We try to send out the notes to everyone who registered. If you registered maybe a little bit late, it could be that that is the reason why you didn't receive the notes. But just quickly put your email address for me in the chat, and I'll make sure that Anita sends you the notes while Jurg is just taking a quick break. Okay, for those who just joined us, Jurg is just on a quick break. He's got a little bit of a frog in the throat. So just a quick break there to get some cold water. We'll resume within 5 to 7 minutes. So if you all just want to take a quick break, I see there's quite a few sending through their email addresses so that we can send them the notes. Just letting Anita know. And again, also please just double check in your spam folders in your email if you have maybe received it in the spam folder. Anyone else struggling to see the notes on the screen? I think one or two left the meeting, the webinar, and rejoined, and then it worked. So if you want to try that, maybe it could be that it's the connection that is causing issues. With load shedding, anything is possible.
Right, Roselle, will we continue?
Yeah.
Was it too early?
No, I think you can continue
It's,
here.
yeah, it's like 7 minutes, just a quick break.
Yes.
I don't want us to go over time because maybe some of you have plans for Valentine's Day. Luckily, I'm too old for that, so I don't need to do that anymore. my wife didn't hear that. All right.
Well, we are recording here, so be careful.
Yeah. All right, ladies and gentlemen, what I'm going to do now is just to explain to you this whole approach. Is that if I just recap, I start with the 3 theorems on center. I explain those theorems, the drawing, the wording, the 3 theorems, and then you can do a few questions that they can see how those theorems work. Then I do the second group on cyclic quarts, 3 theorems and a few questions, and then the 3 theorems on tangents with a few questions. So this is where you lay that foundation. You've covered now the theorems, and you now take it. Problems. These ones are not based on any specific group like the previous ones. These ones are mixed problems, but take note, they're numerical. So that is where you have degrees and so on. Because what I want to discuss with you now is I want to discuss 3 types of questions that the kids must be able to do. They must be able to do numericals. They asked these numerical questions of grade 11 right up to the matric exams. So it is easy marks for the learners, even in grade 12. So my suggestion always is do many problems on numericals, because the children will get used to the theorems, how to use them to solve these questions. But you must do many of them. Don't go into the proof questions too quickly. So numericals is what you now will do. After numericals, you will see we will do problems with variables, and then we're going to finish today with proofs. So if you look at this question, and I believe it's not so difficult, we can see quite a few little things. If I just look at the drawing and I read, O is the center. Now, the moment I see O is the center, there's a line drawn from the center to the chord, and it bisects the chord. So we know that will be 90 because of the theorem. You will also maybe notice, I thought I've seen a cyclic quad. Yes, there is a cyclic quad. Maybe I can just highlight it. That one looks like a cyclic quad to me. So there's a cyclic quad in it, but it looks like there's no tangent. So that means we have 2 of the 3 groups. So that is the whole idea of this. We want not the learners to look for 9 theorems. They must look for which groups are here. And the key words are the center, and if you can see a cyclic quad, and then a tangent. Cyclic, center, tangent. And you know what theorems to look for. In this question, we're not going to use tangents. So we already eliminated 3 theorems. We do have that this angle COP is 123. And those 2 lines are equal, and so on. All right, so what can we find? That is what we now need to start with. All right, so I think a good place to start is to say that P1 is 90, because we're going to use that 90, and we didn't know that, so we need to say it. So let's say P1 is equal to 90 degrees, and that is the line from the center. So P1 is 90. Now, what can we say about A1? Because we are looking for A1. Now, it's also something that we tend to miss easily. And that is, if I can just highlight it a little bit, do you notice there is a triangle, and that is the exterior angle of a triangle, which is equal to this angle plus that one. So a very basic one, exterior angle of a triangle there from the early grades. So we can now say to find A1, we can say A1 is equal to, because A1 plus P1 is 123. So I can say A1 is 123 minus 90 degrees, and that will be 33. Yeah. And the reason for that is the exterior angle of a triangle. And there we have A1. Let's look at B. Now, to get to B, and I want you to watch closely that angle B and angle A, I claim, will be the same because they are both subtended by EC. You see EC subtended B and EC subtended A1. So I can start here and say that angle B is equal to A1. And that is angles in same segment. That is B equal to A1. Now, what do we know about A1? We know that A1 is 33. That we did already. So that means angle B will be 33 degrees. And it's because of angles in the same segment. That was pretty easy. So let's look at number C. We want D1. D1 is that one outside there. That exterior looks like a little exterior angle of that red cyclic quad, that D1. And this angle will be equal to which one? Will be equal to B, and we just calculated B. So I'm sure you're all happy if I say that D1 is equal to B is equal to 33 degrees, and that is the exterior angle of a cyclic. Last one is G. What do we know about G? It is also quite an interesting one. It's not difficult, but just to recognize it, because this drawing's got more lines. If you look at that one, do you all notice that AC is a diameter? And if AC is a diameter, what is angle G? Then we say that angle G is 90 degrees, and that is an angle in semicircle. That's it. There's a typical numerical question. These questions are easily 10 to 12 marks in the exam, only on numericals, and the kids can do pretty well. You will see with these questions, I start to step them up a little bit. The drawings are looking a little bit more exciting than the previous ones we did. This one we have 5 questions, so let's first see what we have. We've got a tangent. TAS is a tangent that we have, is the tangent. So we must keep that in mind. We've got a center. And very clear, we have a cyclic quad. So all 3 groups are in here. So doesn't mean all 9 theorems, but at least all 3 groups are here. So let's see where we can start. We have parallel lines, and we've got the angle of 100, that is BPC, and then C2 as 51. Okay. First of all, they want angle O. Now, if you look at angle O, you will agree angle O is twice B1, because this is angle at center, angle on circumference. So we must find B1, which is easy, because we've got the other two angles. So we can easily start with B1, and to say B1 is equal to 180 minus 151, and 30, what is it, 29? I think so. 29 degrees. I didn't write anything, and that is because angles of a triangle. And because B1 is 29, what will angle O be? It will be double that one, namely 58, and that is angle at center. There you go. The next one is C1. Now, C1 is part of this triangle, and we just calculated O, that triangle. So O we said was 58. So with this, to get to C1, we can say that C1 plus D1 plus D2 plus 58 is equal to 180, and that is angles of a triangle. So C1 is equal to D1 plus D2. They will be equal, and that is, oh, I don't have space here. So if you just can remind you that the reason here is, let me write it down at the bottom, that is angles opposite radii, angles opposite equal sides, or radii. So because we know they are equal, so that means once we take the 58 across, we can divide the answer by 2, and that means we will have C1. So our C1, I think, will be something like 180 minus 50 is 130, 122 for both angles. If 120 divided by 2 sounds to me like 61 degrees. That's it. Right. Number C, they ask us for D1. Now we've got D1, D2 together. We know is 61, but they want only D1. So how will we get there? I think the best way to do it, if you maybe looked at it as well, do you notice the parallel lines? That this D1 and B2 are the same. And this is just a little bit confusing, this 58. Let me just put it down here, 58. So what we have now is that this angle D1 is the same as B2. So how can we find them? We want to get to D1. So maybe we must find B2 first. I don't know if you noticed anything there on that one. I just want to write this in that we can see it. This angle is 29. We did that already, B1. Now, what I want you to look at here is these lines are parallel, those, like that. So do you notice the co-interior? This plus that. So it's B2 plus 29 plus 51 plus C1, which we worked out to be 61. and that is co-interior angles. So to find this D1, I'm just going to do it up here. I'm going to say that B2 is equal to 180 minus 29 plus 51 plus 61. 29, if we can just show you, 29 plus 51 plus 61, because that gives me the co-interior. And that means we have B2. So if we add those, subtract from 180, then we will get 39 degrees for B2. The question was not B2, the question was to find D1. But B2 and D1 are the same. So that means D1 is 39, and that is alternate angles. And we must mention the parallel lines. All right, so 3 down. Let's look at number D. They ask us for A1. Now, A1, if you look at it carefully, I think it's really quite nice, because A1 is the exterior angle of, so not the exterior angle, the angle between a tangent and a chord equal to the angle in the opposite segment. So A1, we can write it down straight away, because A1 is equal to B2 is equal to 39 degrees. And that is the tan chord theorem. Straightforward. The last question is A2. Now, if you look at A2, that is part of the cyclic quad. So there's your cyclic quad. So this angle plus C is 180, but we know what C is. So I think you are happy that it's easy to find A2. So we can start by saying A2 is equal to, and we're going to go 180 minus, and that is 51 plus 61. And then we can write down what A2 is, which will be 68 degrees. My reason is opposite angles of a cyclic. Opposite angles, that A2 plus C is 180. So these are examples of questions with numericals. I say again what I said before, please do as many as possible of these questions. They really need to get this practice on these questions. My second group of questions. So we've got numericals. Now you will see we move to problems with variables. That is where we, instead of getting degrees, we get X. As you can see here, angle B is X. It's there written in the drawing for us. So we don't have degrees. I always say to the learners, if I said to you B was 30, you can work out other angles. But now you say it's X, so the other angles will be in terms of X. So let's see, there are also two lines equal. Those two lines are equal. That angle is X. O is the center. O is the center. You see the line drawn from the center. That bisect the chord will be perpendicular. So that definitely will be 90. And what else? Something else I notice is that there we have angle at center, and there we have angle on circumference. So O2 is twice B. And by the way, that is the first question. So we're going to say that O2 is 2 angle B is equal to 2x. And that is angle at center equal to twice angle on circumference. So that was not too bad. Then we get to angle A. We want to get to this one. Now, the moment we want this angle, it is really important that we need to mention that F1 will be 90. So I'm going to say F1 is 90 degrees, and that's the line from the center. So we have angle F1 as 90. And we want angle A. So how can we get it? Again, not too difficult. Again, it's a very easy little definition. And if I can just highlight it a little bit for you, that you can all see it. If you look at that triangle, and the exterior angle, which is O2, is equal to angle A plus F1. So it means we can say that angle A, how will we find it? Angle A, we will take angle O2 and we're going to subtract F1. And that is the exterior angle of a triangle. So now if we just substitute, because we just calculated O2 as 2x, minus and F1 is 90. And there we have it in terms of x. Very popular, these questions. They sometimes ask the question to say, find 3 angles equal to x. So that means they will be x. This one, you will notice, I say, find the sizes of the following angles in terms of x. So that is a 2x, a 180 minus x, or a x plus 90, or a 2x minus 90. That's in terms of x. All right, so that is a problem on variables. This one, I don't know what happened, but there's supposed to be a heading here that says proofs. So you can maybe just write it down. So from here, we're going to look at problems where they ask us to prove something. So if you read this one, you can see this question is also getting a little bit more exciting now. And we say here that in this one, we have a tangent. This ECH is a tangent. And BC is a tangent. But that's now to the smaller circle, BC. And that's it. And then you notice in the big circle, there's a cyclic quad. So we've got tangents, we've got cyclic quad, but we don't have any center. So all theorems on center out, we only on cyclic quad and tangents. So now they ask us to prove BC. I think I just need to highlight them that we can just see them. BC equal to CD. Now, I think you will agree with me. They ask us to prove those two sides equal. I think what we need to do is, let's start. No, I'm going to phrase it a little bit different. I'm going to say prove B1 equal to D1. If we can get D1 and B1 the same, then the two sides are the same. I think you will agree with that. So let's see, what do we have that we can get? So I want to get to D1 and I want to get to D1 and to B1. So what do we know about all of this? We do know that B1 is the same as, just have a look at A1. Yes, this angle is equal to that. That's the tan-chord theorem because this BC was a tangent. So let's write that down and say that B1, because now we already find an angle for B1, is equal to A1, and that is tan-chord theorem. What do we know about A1? Because of the cyclic quad, do you agree that A1 will be D1? So I can say A1 is equal to D1, and that is angles in the same segment. But didn't we get it? We've got B1 is equal to A1 tan-chord, A1 equal to D1, angles same segment. So what can we now say? We can say that B1 is equal to D1. So therefore, BC is equal to CD, and that is sides opposite equal angles. So as you can see, they do get now a little bit more exciting. And I believe that when we do those theorems in the groups and we discuss the easy questions, and then we move on to the mixed numericals, and then we move to the variables, and lastly, we get to the proofs. And ladies and gentlemen, when we do these proofs, once we've done that, that is where I suggest you prove the 4 theorems that's for exams. For understanding, I explain all 9 theorems because they must be able to use all 9 of them. In terms of proof, only 4 of them. The very first one, line drawn from center, angle at center twice angle on circumference, opposite angle supplementary, and then the tan-chord. So 1 from tangent, 1 from cyclic, 2 from center. And that is what you must do with your learners. But do the proving of the theorems right at the end. All right. So let's move on to the B part. In this part, they ask us to prove 2 sides parallel. And that is BD. So I think I'm going to highlight them that we at least can see them. BD. And I want to prove it parallel to EC. So we want those 2 sides parallel. Now to prove parallel, it's most of the time alternate angles or corresponding angles or co-interior. And we must now see, can we get that? Can we get something like that that we can prove it? So what we know up to now is, from our previous one, you see this B1 is equal to A1 is equal to D1. So I'm just going to mark them on this as well. So A1, B1 equal to A1 equal to D1. Any other angle you can see? I think C1. If I look at C1 and I go for this triangle, then it looks like it's the same as D1. So I think that will also be a black dot. That's what I think. And what else do we have? Don't we have A1 and C2? I almost think so. I just want to go and check quickly. What did we prove? We prove those 2 sides equal. So B1 and D1 are the same. Okay, but I think we've got enough to solve this. All right, so where will we start? I will start off by saying that angle C C1 is equal to A1. C1 is equal to A1. I used that triangle. But of course, we can use this one as well. But C1 equal to A1 is tan chord theorem. And then we already proved A1 equal to B1. And that we've done in the previous one. A1 equal to B1. Those two are equal. And that we set in the previous one. So what can we get from this? If C1 is equal to B1, but B1 is equal to A1, what can you now say and get from that? That C1 will be the same as B1. C1 the same as B1. But aren't they alternate angles? So that means we can now say that BD is parallel to EC, and the reason is alternate angles equal. Because the angles are equal, they are parallel. If they're parallel, the angles are equal. All right. I think there's still a C part to the same question. And I'm just going to quickly put these little dots on that we just remember which angles we already have equal. And we also have this line now parallel to that one. We can use that as well. And now they ask us that we must prove AC bisects BAD. Now, this bisect is, kids find it difficult, so I would rather say we must prove A1 equal to A2. A1 equal to A2. If A1 is equal to A2, then it means AC bisects BAD. We've got this one, so we want to get this one the same as that, or any one of these. So now you must look at this drawing carefully. So I'm just going to highlight this cyclic quad quickly. There it is. Now, if you look at that cyclic quad, then we do know that this angle is equal to that. It's angles in the same segment. But isn't this B1 the same as A2? I was just thinking this may be an easier way to do it. We want to prove, but yeah. And for a moment, I'm in a doubt between two ways. So what I was thinking of, we know that this one will be, we proved this one equal to D1, but this one will be the same as that one. And I think that is what we need to do. Okay, I notice another way. I will tell you about the second possibility, but let's just do this one. I will say that B1 is equal to A1, and that is what it's proven. And now what else can we say? That B1 is equal to A2, angles in same segment. So what does that mean? That A1 is equal to A2, so therefore AC bisects BAD. So there we have it. So that is 100% fine, But I just want to quickly show you something else, which I think you would like as an alternative solution. I'm just going to clear it. You will remember in the first part, we proved this side equal to that one. So that was in A. Now, because they equal, I want you to look at the angle on the circumference for this one. And I want you to look at the angle on the circumference of this one. So do you notice that this BC subtends A1 and CD subtends A2, but they are equal. So therefore A1 is equal to A2. So we can do that. It is 100% valid. So we can we can now, from this one, all I'm going to start with to say is that BC is equal to CD, and that is proven. And then we can straight away go and say A1 is equal to A2, and that the reason for that is equal chords, equal angles. So equal chords subtends equal angles. So it's a variation of the angles in the same segment one. So you would see this one way shorter. I apologize, sorry. But the second one much easier, but they find it difficult to see that one. So maybe the first one, the kids will be able to see easier. All right. So let's see. I think I've got another one on proofs. Yes. This is quite an exciting one. Nothing given, only a drawing. And you will notice.
Sorry, Jurg. There's just a quick question here from Fatima. I don't know if you can see the chat. Otherwise, I will just read it to you.
No, I don't see any chat. Is that on the previous problem?
Okay, she's asking learners often want potential mark allocations are for these questions to guide themselves how many steps they should aim to write so they don't overkill. Could you include mark allocations for these examples, please?
I can certainly do this. We will not have time to go back to the previous ones, but from this one we can do it. Is not a problem. There is an easy way sort of to remember, and that is, first of all, in terms of mark allocation, if we look at the numericals and they ask for an angle, sometimes what we have is enough and we can write down angle A is 20 degrees. And then a reason, and that is normally 1 mark each. So a problem like that will be 2 marks. If there's more than 1 step to get to the answer, it will go to 3 marks. So always the reason as well. But let's discuss this one and we can see what we can say about the mark allocation as well. I don't mind at all. So they ask us in the first question that we must prove that C1 plus A1, so it is this angle, and A1 must be equal to D1. Now, where will we start with this? Always remember, we would like to use some of these ones. Because if we use some of these, we can hopefully see what they want from us. So let's see what we can do. Is there anything we can say about D1? I think we can say D1 is equal to C1 plus E. Because we want C1 as well, and we start with D1. So I think that's a good place to start. So I will say D1 is equal to C1 plus angle E. And that is the exterior angle of a triangle. D1 equal to C1 plus E. But what do we know about E? Anything we can say about E? And if I can just highlight it, do you see that's an angle on the circumference, and there's an angle on the circumference? So it's angles in the same segment. So that means we can now say that, but angle E, because I don't want the E, I want the C1 and I want the D1, but E is the same as A1. That is angles in the same segment. So now we can say C1 plus A1, because instead of the E, we now put A1 is equal to D1. Now, if we think of a mark allocation here, I will certainly give a mark for that and for the reason, for this and the reason, and then the conclusion. So my idea here is that it's around about 4 to 5 marks. The examiners not always indicate the marks exactly like it, but I think it's fairly accurate if we say it's around about 4 to 5 marks for this one. So my indication to the learners normally are that if a question is 2 to 3 marks, it's normally, you can do it in 1 or let's say 2 steps, 1 to 2 steps. If it's closer to 4 or 5 marks, you need 3, 4 steps to do it. They maybe will add another step. Sometimes they want to put something else in, which is not always necessary, but it's not a problem. It's just for you guys difficult to mark. So let's look at the B part. This one is also approved, C1 plus S2 equal to B. C1 plus S2. Now, if I look at C1 and I look at S2, I think you will agree with me. It will be equal to D1 plus D2 because that's the exterior angle of a triangle. So that's what I think we must start with. So I will say C1, because that's what we've got, plus S2 is equal to D1 plus D2, exterior angle. So this is the exterior angle of a triangle. But what do we know about D1 plus D2? Very interesting. Do you notice anything about D1 plus D2 is equal to angle B? Will be equal to that. And what is the reason? The exterior angle of a cyclic. You notice that we have a cyclic here. Where is that angle B? I just want to check it. There it is. If I just extend that one and I bring this one down, you see the exterior angle equal to the opposite interior, exterior angle of a cyclic. So that means now that we can now say that D1 plus S2, which we said was D1 and D2, but D1, D2 is B, we can now call equal to B. And this one will be more or less 4 to 5 marks as well for this question. Okay.
Jurg, sorry,
Yes.
also before you continue, Christelle mentioned that the examination guidelines has changed in 2021. There are now 5 grade 11 theorems to be proved. Theorem 1 and its converse are required to be proved.
Oh, okay, yeah. No, sorry, I didn't say it. Thank you very much for that. I didn't say it. I just took them as one theorem because they're so similar. Yeah, it's those two that we spoke about on the first theorem. So thank you, Gustav. It's definitely so. You are quite right. I want to finish this session with two problems that I had to discuss with you. And these are very specific ones, but very, very popular questions, which I think is a definite that we must look at them. And you will notice the heading. I did problems where they say prove something, angles bisect, this angle equal to that. But then we get to specific kinds of proofs that they love in grade 11 and 12. And the first one is to prove that a quad is a cyclic. So we want to prove a cyclic. And then the next one we're going to do is to prove a tangent. So I would like us to quickly look at these two kinds of ways to do it that we have. So if you look at this question, I say here in the following sketch, EF is a tangent. So there is a tangent, EF. And AB is parallel to BF. That is also on the drawing. And they say now, prove that BEFC is a cyclic quad. Now, when we want to prove a cyclic quad, we basically prove the converse of those theorems that we spoke about. So we can prove opposite angle supplementary, then it will be cyclic quad. We can prove an exterior angle equal to the opposite interior. Or we can prove angles in the same segment equal. Then it is a cyclic quad. So let's see, what do we have here? BEFC we want to prove. So if I start with E1, will you be happy that it is the same as angle A because of the tan chord theorem? So I think what I can start with is to say that angle E1 is equal to angle A, and that is tan chord. That E1 is equal to A if you follow the triangle, and there's the tangent, and the angle between a tangent and a chord equal to the angle in the opposite segment. But what else do we know about angle A? Angle A is the same as B1. So this angle will be the same as that one because the lines are parallel, and that is corresponding angles. And we must always mention the parallel lines. So what do we get from this? We got E1 is A, but A is B. So we have that E1 is equal to B1. Now, if E1 is equal to B1, that's what we have now. Do you notice that they are angles in the same segment? Then we can now say that BE, where is it now? FC is a cyclic. And the reason, line subtends equal angles. So we have a line that subtends equal angles. And that is why it's a cyclic quad. So it's the converse of angles in the same segment. This is the A part. There is also a B part, where this one, you can notice it's the same drawing. But now the question is, we must prove ABDE is cyclic, but now there's something else given to us, which is not on the drawing. So that is quite important that we must have that. So AC is equal to EC. So AC, I'm just going to say AC is equal to EC. I mess up the drawing, but we just remember those two sides are equal. So I pretty much think that you will agree that if those two sides are equal, then A and E2 will be the same. All right. So where will we start? We know that angle A is equal to B1. So let's start there. B1 is equal to angle A, and that we've proven. We can also say corresponding angles. And then we also know that angle A is the same as E2. Angle A is the same as E2, which I mentioned earlier, so we can make them little dots, and that is because of the fact that those two sides are equal. So it's angles opposite equal sides. So what do we have from here? We have B1 is equal to E2. B1 equal to E2. I didn't highlight the quad. I just want to do that now. Should have done it. ABDE. A ABDE. We want to prove that a cyclic quad. So what we proved here, we proved B1 equal to E2. Isn't that the exterior angle of a quad? So that means we've done enough. So we can now say that ABDE is a cyclic quad, and my reason is the exterior angle of a quad equal to opposite interior. So we proved the exterior angle of a quad equal to the opposite interior, and because that is true, it is a cyclic. All right. So that leaves us with one question, and luckily it's a fairly easy one to finish with. And that is where we want to prove a tangent. Now, again, we most of the time almost use the tan-Colt theorem for it, but also radius perpendicular to a tangent that we can also use. But that one is not here because there's no center. There are angles given to us. And so that means we can, if this is 52 and they parallel, then that will be 52. I don't know which angles we need. And they ask us to prove AB is a tangent. So AB looks like a tangent, but it was not given. They say we must prove it. So we must prove then A1 equal to C2. So if we can prove A1 equal to C2, we know it will be a tangent. So where do we start? I will start with angle D. So I will say that angle D is equal to 52, and that is alternate angles, the parallel lines. And then I can say that C2 is equal to 180 minus 80 plus 52. And that is, of course, angles of triangle. And that will give you 48 for C2. Then I say, but A1 is equal to 48. That was given. So that means that A1 is equal to C2. So because those angles are equal, we can say AB is a tangent. And the reason is converse tan chord. So it's not a difficult one, it's a numerical one again, but it's a problem, types of questions you need to cover with your learners. So ladies and gentlemen, it's 2 hours. It's on my watch now, 2 minutes past 5. So I'm almost on time, pretty close. I believe this will help your learners. I use this now for many years with excellent results from learners who say geometry, they don't find it so difficult anymore. So please don't just discuss theorems, discuss the 3 groups, then you do numericals, then you do variables, then you do proofs. Thank you so much for listening to me and spend your afternoon with us, and enjoy your evening, and hopefully we talk soon. All of the best.
Thank you, Jurg. We appreciate it. I was just, before you leave, is there anyone that wants to ask a question? We can, I don't know, Jurg, if you've got a few minutes, if there's someone that's got a question, you can just raise your hand and then I can open the mic and the video and they can ask their question. So if there's any questions, please raise your hand. Okay. So someone asked, Nontlantla. Okay, she wants to ask a question. Okay, I'm just going to open her mic and her camera. Okay, you can ask your question. Let's just see. I have opened the mic. Nontlantla, try again. I've opened your mic there. Okay, I don't know. It seems like the mic is not working. Sia, I've opened your mic. Try and see if you can connect. Okay, Nontlantla was asking for a webinar for grade 12. So yes, that's what I wanted to mention. The 28th of February, we are going to have the one for grade 12. So we are sending out invites just after this webinar, and you are on our mailing list. So you will receive an invite for the grade 12 one, which is going to happen on the 28th of February.
Yeah, it's in 2 weeks' time, ladies and gentlemen. Also Wednesday afternoon, 3 to 5, where I will then discuss with you ratios and similarity. We will only cover those 2 topics, unfortunately, in the 2 hours. I'm looking forward to see you all guys again and to spend time with you. So you must have a great evening. I don't know if there's anyone else who's got something. I'm not in a hurry, but
I have opened Sia's mic. I don't know why they are not allowed. I've opened the mic and the camera. Sia, do you want to try again? Let's see if we can get you. Okay, doesn't look like it. Okay, Sia says he's trying. Otherwise, you can just type your question, Sia. Okay, so Sia's just going to type his question quickly.
There was one person who just came up who said, but it went out. He said, Rizal, he asked if they can access it again, but I think he may
Yes,
be.
yes. Yeah. So we are going to send the recording to everyone who attended. We've got you on the list, so we will share the recording with you, and we are going to post it on YouTube. We have a Mind Action Series YouTube channel. Please check that out because there's a lot more videos on that channel also. Jurg has posted quite a lot of, we've posted quite a lot of videos there from Jurg discussing certain topics and so on. So please go and check that out. But we will post the recording on YouTube and share it with you, the link with you after the meeting. So yes, size points are going to be allocated. We are sending the list of attendees through to them with your points that you've noted on your registration. So we are sending that all through to SAIS and they will allocate the points to you. Jurg, can you see that question from Sia in chat?
Yeah, I saw the first part. It's something to do with Pythagoras, but I didn't get the rest.
If you just maybe scroll down a bit.
No, it disappeared again. So I don't know how to get it.
Okay, he asked, is it a must to go after the statement to write, I'm not going to pronounce it correctly, Pythagoras? Is there a mark for that?
I want to believe so. Yeah, I want to believe so. They not always give marks, I want to say, for easy reasons. But there is a chance, but you can't say for sure a definite. But there's a good chance. So whenever you use Pythagoras theorem to find a side like those very first questions, then you must give the reason as Pythagoras, and I want to believe it's maybe. You see, sometimes they don't give a mark, but if you don't do it, they subtract a mark. So that's sort of the bad thing. But difficult to say how the exam panel, how they see it. They sometimes, I notice sometimes a question with an answer and a reason, they give 1 mark. And another time they give 2 marks. So not always they do exactly the same. I hope you are with me. Okay. Thank you, Sia. Okay. Anyone else with anything?
I think that's all, yeah?
Yep, it looks like it.
Yeah. Okay, thank you so much, Jurg. Much appreciated. We'll see each other the 28th.
Yes, thank you for yourself, Rizal, as well, for all the invites and setting up this whole thing. You make it so easy because still see there's many people, but this technology is not always easy for me. Yeah. I prefer mathematics than technology. Okay.
Thank you,
you must have a good evening.
Yeah, everyone enjoy a lovely Valentine's evening with your loved ones, and we'll see each other again.
Yes. Keep well. Bye.